We have covered almost all tests, few tests I kept it there. I'll describe as this course will go on. I do not want to spend particularly subsoil investigations, it is a kind of outlook and brief description. More focus on this course is on foundation design. Now, before we conclude, based on this subsoil investigations, and you need to have your design parameters and soil data. This you have to provide your design engineer. So, what are the informations given regarding your subsoil investigation? First one is your engineering geology, second one is your topography, third one is your past history, fourth one is your soil stratification, and fifth one is your depth of rock and water table, sixth one is your engineering properties of your soil, then last one is your design recommendations. So, in that particular that report, slightly you have to give your project descriptions. What project description you are going to give it? Particularly you are going to give general level or site description with respect to adjacent area, then your problem of your waterlogging, or you can say that drainage, then surface investigation. So, basically for example, this is the area where is your proposed constructions, this is your planned structure, and there is a pond here, nala or pond is here. Then suppose for example, nearby already there is a playground existing, then there is a existing building. Then basically how do you take a call, even if there are different thumb rules, you can take corners 1, 2, 3, and as there is a pond nearby, so you can consider 1 point for your boreholes, existing building 1 point here, or playground you can put it here. So, basically this your site descriptions means project report reveals test locations. Your project report in detail it will reveal what are the test location, what are the tests you are supposed to do, and any information about the weak soil near the site or nearby the sites. Then next is your, I have discussed method of investigations. Next you have to go for your method of investigations. In method of investigations there are two parts, one is your laboratory, one is your field. Generally in the field you go for borehole and SPT or any dynamic test, then your laboratory test to find it out engineering properties and classifications. Means suppose you are conducting a borehole here, for example one borehole say up to 30 meter. So, you are collecting soil samples every 2 meter interval. That means from every 2 meter interval you are supposed to get disturbed as well as undisturbed samples. From disturbed samples you can classify the soil so that you can get soil stratifications as well as engineering property, that means C5. This, after collecting the soil sample you go to the lab and do your test, and sampling, while doing the sampling you should be very careful about your undisturbed soil samples. As far as possible you should collect undisturbed soil samples. This is what is your method of investigation. I have finished. Now how you are going to, this is most important, how we are going to report this, what you get it. One is your laboratory report, one is your field report, and before that is your preliminary investigations, soft soil investigations, that carries a report. Then once your laboratory and field test is over, you have to prepare in a data sheet, that is called data logger, For example, I am just showing it, I can show you in a PPT also, and this is your ground level and this is your depth. Suppose I put it 0, 3, 6, 9, 12, 15, 18, then suppose 21, every 3 meter. Suppose there are two boreholes, draw it like this. I will show you a PPT also, data loggers, mark it. This is your BH1, then another one is your borehole 2, any number of boreholes whatever you have decided, this is your borehole 2. Now every depth you mark it. Then what is your classification? In this case it is clay, in this case it is silt, in this the clay is continuing, all of a sudden it changes. Suppose this is grey clay and this is your clay silt, and there is a water table at the ground surface, you mark it. Then at the same site, for both these cases you mark SPTN, this is your SPTN per 30 centimeter. You just show how it is varying, borehole 1 as well as borehole 2 SPTN. Also you show in a data logger what is your natural moisture content. Once you collect undisturbed sample, you will get your natural moisture content, and depth wise how it is varying natural moisture content, as well as also gamma, unit weight of your soil, that also you can say that how it is varying with your depth wise, that also show it. So, this basically this is a data logger. Once this data logger the design engineer see, he can say okay, between 0 to 9 meter it is purely clay soils, and put the value undent cohesion, what is there undent cohesion, if there is a silt, what is the value of C as well as phi, all details engineering property you have to put it. Okay. This layer from 0 to 6 meter or 0 to 9 meter, this is a clay soil of undent cohesion is almost varying layer wise, this value is this is this for borehole 1. Now, for borehole 2 there are 2 boreholes, suppose for example you have taken. So, from 0 to 9 meter it is silt, in 9 meter to rest it is clay silt. Clay silt. Now, what are the properties? Then you have also carried out your SPTN, how your SPTN is varying different locations, what is your natural moisture content is varying, what is the gamma it is varying, basically what is the gamma it is varying. Now, particularly if you look at what are the tests you are supposed to carry out in your laboratory, basic test. So, classifications, one is your classifications. So, basically in classifications you have to find it out, bulk density, natural moisture content generally written W or omega, Atterberg's limits, limit, then grain size distribution, then is your second part, this is part 1, second part is your engineering property. In engineering property what you are supposed to get it from your undisturbed soil samples, shear strength parameter, then permeability, then is your consolidation data, consolidation data for what? For settlement calculations, then compactions. Then is there any, if it is organic soils, then you have to go for chemical test. So, this is all about your, particularly in bore log data you have to show it. So, once this information got it by the design engineer, he will take a call what kind of foundation and at what depth, what is the dimension of your foundations to be designed. So, in brief I am saying all things I covered, design parameters and soil data, basic information you prepare it, write it, project descriptions, that means where it is located, nearby what are the existing buildings, roads, playgrounds or any nala or any pond it is there, you prepare a map. Then method of investigations, both laboratory and field test you have to take a call, how many number of boreholes and what depth you have to go for the boreholes, and what are the samples you are collecting, whether you will go for SPT or CPT you take a call. Then at the end prepare a data log, all information in your data log. Then what are the different tests you are supposed to do, basic test in your laboratory. First one is your classifications, bulk density, natural moisture content, Atterberg's limits, grain size distribution, engineering properties, shear strength parameter, permeability, consolidation data, compaction. If it is organic soil, then you prepare, go for chemical test. So, I will show you some video or something in PPT form, I will show you. So, how it has been prepared, it will be more way to see. So, before preparing your bore log, data bore logs, so particularly it will be name and address of drilling company or agency who has done the drilling, right, collected on desktop soil sample, driller's name, job descriptions and number, means if it is a multi story or multi places you are doing job 1, job 2, job 3 and number, how many number of numbers you are doing, number, type and location of your bore holes, this is most important, number, type and location of your bore holes, how many number, what are the type of bore holes and location of the bore holes, date of the boring, that is more important, subsurface stratifications, stratification means every depth wise is there any variation, that has to be shown, which can be obtained by visual observations of the soil brought out by auger, split spoon sampler and thin walled selvitube samplers, evaluation of water table and date observed, use of casing, moduluses and so on, standard penetration resistance and depth of SPT, number, type, depth of soil sample collected, this is also more important, number, type and depth of the soil sample collected, I have explained. In case of rock coring, type of core barrel used and for each run the actual length of coring and length of core recovered, all this data before preparing it you keep in your mind. Now look at here, this is a boring data bore log or boring log, we generally call boring log. How it is there? Name of the project, 2-story apartment building, locations, date of boring March 2, 1982, boring number, number 3, that means earlier there are also 1, 2 boring, type of boring, hollow stem auger, how you use it, by means of auger boring, it has been done by means of mechanically or you have done by means of drilling machines, ground elevation where you are doing the boring, ground elevation 60.8 meter, look at here, this is just for example, depth put it 1, 2, 3, 4, 5, 6, 7, 8. Now if you look at here, initial phase up to 0.5 meter, this is a filling soil, this is a particularly filling soil, this filling soil is your light brown clay, right. Then there is a silty sand and also I put it classifications also, it has to be put it, if it is a silty sand, what is the actual engineering classification, it is SM. This silty sand is varying, if you look at here, this is your 0.5 meter, it is up to your 3 meter, there is no change of your profile from here to here, same soil profile is there. Then what is your SPTN value, particularly this depth, SPTN is your 9, then moisture content is your 8.2, 8.2. Now come back here, groundwater table is located at 3.5 meter. The symbol as I said earlier, groundwater table you put it, then put it like this, it should be very clear, legible and it can be very distinguished, somebody can see, oh, groundwater table is at 3.5 meter. Then here light grey silty clay ml. Now this, look at your SPT, from 3 to 6 it is 12, 6 to 7 it is 11, 8 is your 27, sand with some gravel, beyond this it is not possible to go for a SPT, because you are getting a hard stone or sand, it is not possible to collect it. Now where you can find it out, liquid limit, plastic limit, that you mention it. This is how your bore log data says. If you are carrying out, now this is only information about boring, classifications, SPTN, natural moisture content. If you have carried out any dynamic test, seismic zero, seismic downhole, seismic crosshole, though I have not gone yet dynamic test, I keep it some part around the lecture during your foundation design, machine foundation, there I am clubbing it. So, there what you are supposed to get it G, low strain shear modulus G, as well as your shear of velocity, and anywhere else there is a liquefaction or earthquake, then you have to go for shear of velocity as well as pore water pressure measurement. So, this will continue, all the parameters will be there. Once design engineer got these parameters and brief description about the site, then they will take a call where first part is your depth of your foundations. Second, very most important, whether you will go for a shallow foundation or deep foundations. If you go for a shallow foundation, what kind of foundation you are supposed to do? Okay, strip, square, rectangular, I will go for this. Once you go for that foundations, at what depth you are going to put it? Okay, depth is 1 meter below the ground surface, fine. Then once you put it, then what should be your size of your foundations? If it is a square 2 meter by 2 meter is enough. That does not mean that if you have to put it a shallow foundation 10 meter by 10 meter, the cost of your foundation is much more than your actual superstructures. There are some limitations, some experience, some judgment has to come into picture. Then what kind of loading coming to the structures, all calculation design engineer will do, and they will take a call. Look at here, this is only 2-story apartment building. Sometimes you go for a 10-story, 15-story, 20-story. In metros, there also raft foundation has been used. It is a 2-story building. So, very simple 2-story building, you can go for a shallow foundation, either you can go for a square or isolated footing or rectangular footing. Then decision you have to take a call what kind of foundation. This is what your basic requirement before your design, and this part as an geotechnical engineer, as a design engineer, you have to interpolate. As an geotechnical engineer, you have to give this. If someone is working as a geotechnical engineer, both he has sometimes in abroad, sometimes in US, some places they take only one geotechnical engineer. So, you have to do subsoil investigation and look at the report. Also you have to do some structural design, foundation designs. These are 1:1. So, this report, based on this report, other calculations has to be carried out. If there are wrong reporting these values, this may lead your faulty foundation designs. So, this is a preliminary, this is basic subsoil investigation, then followed by your foundation design as well as your analysis. This is where I want to stop it, because this covers your complete subsoil investigations. Now, I will start next part, just in brief I am starting, then I will go for in details as the following classes. Now, just this is basic introduction I am starting. So, first part is over your subsoil investigations. Before I go for your bearing capacity, settlement analysis, Terjaghi bearing capacity, Meroff bearing capacity, water table corrections and all other things, just in brief, foundations. If I say very simple way, before design foundation, I can put it in a 2 basket. One is your shallow, other is your deep foundations. So, shallow foundations, again I put it footings, then second one is your raft. In footings, I put it isolated, then combined, then is your strip. I will discuss one by one. Then raft, I put it in 2 category. One is your conventional raft. Sometimes it is difficult to write, particularly in this pen. So, then buoyancy raft, then deep foundations. In deep foundations, particularly I put it in pile, caisson or well foundations. So, pile raft, pile, these are all coming. This is all total. If I make it not making you confused, the foundation basically classified into two types. One is your shallow foundation, second is your deep foundations. In shallow foundations, I classify into two parts. One is your footing, other is your raft. In footing, first one is your isolated footing, second one is your combined footing, third one is your strip footing. Isolated, combined and strip. And raft foundation, it has been classified into two: conventional raft and buoyancy raft. And deep foundation, if I make it into two parts, one is your pile foundation, other is your caisson as well as retaining walls. This is all about your foundations. Another part, machine foundation, will come into picture. If I classify into two parts, shallow and deep, that is fine. Another is your machine foundations. Right, this is your machine foundation. Third part is most important, that is also part of your geotechnical, that is your retaining structures. That part is your retaining structures. If I put it retaining structures into parts, gravity retaining wall, gravity retaining wall, RW means retaining wall, then cantilever retaining wall, then counterfort FORT retaining wall, right, then RE walls. RE walls means reinforced earth walls. This is required retaining structures because you have to elevate, particularly there is a low lying area, road is here, you have to elevate, at certain height by means of a wall. Then other side you fill soil so that here road can be passed. This is also most important. This is what all design aspects we are going to discuss, and I will go in brief what are the classifications, what are the different types of foundation in brief, maybe one lecture, then I will go for your bearing capacity, settlement, all other things. Thank you.